Welcome to EDU World Space.
For this problem on the topic of telescopes, we are told that a telescope is constructed using two lenses, the objective and eyepiece. The focal lengths of both are known. We are told that the object being viewed and the final image are at infinity, and asked to calculate the angular magnification of the telescope, the height of the image formed by the objective of a building that is a given distance away and a given height, and the angular size of the final image as viewed by an eye. Firstly, for part A, to calculate the angular magnification, we know the two focal lengths. The focal length of the objective, f1, is 95 centimeters, and the focal length of the eyepiece, f2, is 15 centimeters. And so simply to calculate the magnification for the telescope, we know that m is equal to minus f1 over f2. So that's minus 95 centimeters divided by 15 centimeters. So 95 by 15, and we get the magnification, angular magnification of this telescope to be minus 6.33. And that's our first solution. So now we have the angular magnification of the telescope. Now, secondly, in part B, we are asked to find the height of the image. Now we know the distance s to the object is 3 kilometers, or 3 times 10 to the 3 meters. Now s prime is equal to the focal length of the objective f1, which is 95 centimeters, since s is very large. So the distance is much greater than this focal length, 3 kilometers. So we can appropriate s prime to be f1. And so we can first calculate the magnification m. We know this is minus s prime over s, which is minus 0.95 meters, 95 centimeters, over the distance to the object, 3 times 10 to the 3 meters. So the image distance over the object distance gives us the magnification, which is minus 3.167 times 10 to the minus 4. And so with this magnification, we can find the height of the image that is formed by the objective. And so the height of the image, y prime, is equal to the magnification m times the height y, the height of the object. So this is the absolute value of 3.167 times 10 to the minus 4. This is a 4 multiplied by the height of the object, in this case the building, has a height of 60 meters. And so we get the height of the image to be 0.0190 meters. And we know that this is 1.9 centimeters. So here we have the height of the image formed by the objective of the building. Now, finally, we are asked to calculate the angular size of the final image as viewed by the eye, which is very close to the eyepiece. So we know the angular magnification of the telescope, calculated in part E. We need to calculate theta prime. Now we know the angular size for the object, theta, is 0.019 meters over 0.019 0.95 meters. And so this angular size is 0.02 radians. And note that this is also the angular size of the object for the objective. So this is using the eyepiece. And the objective also gives 0.02 radians. Now we can use the equation that the magnification M is equal to the image size over the object size. So that's theta prime over theta, but we want to calculate theta prime, the size of the image. So rearranging this equation, we get theta prime is equal to the magnification M, which we've calculated, times the object size theta, which we've also calculated. So we get theta prime to be minus 6.33 times the object size 0.02 radians, which gives us the image size of minus 0.127 radians. The minus sign here shows that the final image is inverted.